All right, Honors Chem. We're going to continue with the answers video. This is part 2 to lesson 12 in stoichiometry in grams. Okay, and we're on problem number 2 right now. So here we have what's called a combustion reaction. It's a hydrocarbon or a carbohydrate. Hydrocarbon just is a CH compound. This is called ethylene. You combine it with oxygen, and then also you have to light a match. That's what combustion means. It means burn. So you ignite it, and what you produced is carbon dioxide and water. So all combustion reactions involve some sort of hydrocarbon or carbohydrate. Carbohydrate would be a CHO compound, but then they all have oxygen, they all produce carbon dioxide, they all produce water. So you'll see this form of a reaction quite a few times. Okay, so let's get going on this. The first thing we have to do is compute molar masses. So I'm going to explain the first one and then the rest of them. You'll get to where you have these memorized, but I'll go ahead and explain the first one. So for C2H4, we have a carbon. We have 2 of those, and the molar mass for carbon right here is 12.01. And that's going to give us 24.02. For hydrogen, and I didn't write that correctly, it should be a 4, H4. So for hydrogen, we have 4 times 1.01. It's going to be 4.04. And now we just add those two. And it's 28.06. So right here, 1 mole equals 28.06. You can stretch it up there a little bit like that, okay? O2, let me just explain it, and then, but be sure you know how to do it. There's 2 oxygens. By the way, don't worry about the 3. Don't let that confuse you. You're interested in 1 mole here. This is 3 moles of O2 in the reaction, but in terms of the molar mass, it's always set to 1 mole. So what is 1 mole? Well, oxygen is 16, and you have 2 of them. O2 has 2 atoms of oxygen, so that's going to be 32. So this one's going to be 32. CO2. It's going to be 12.01, and then 2 times 16 is 32. So 32 plus 12.01 is 44.01. And water is one you'll see almost every day. It's 18.02. It's 2 hydrogens and 1 oxygen, and that's what you get there. So now you have your molar masses ready to go. Okay, so let's get going on this then. So how many moles of H2O will be produced by 3 moles of C2H4? So moles means we're up here in the chemical equation, and they want to know how many moles of H2O. So that's a question mark. And we want to start with 3 moles of C2H4, so there's a 3. Okay, so this is a 1 conversion problem. You're going from moles to moles. Okay, so that's a single conversion, and you're interested in this. And now I didn't put a coefficient there, but why don't you put a 1 there just to emphasize that that's 1 mole of C2H4, and we're interested in this, H2O. We don't care about these for this particular reaction. All right, so let's go ahead, and what we're trying to find is over here on the right, so it is some number of moles of H2O. And over here we start with, well actually here we start with 3 moles of C2H4. Since we're just going from moles to moles, it's a 1 conversion problem. Okay, and what is our conversion again? It's 1 C2H4 for every 2 moles of H2O. So we're going to set that as an equation down here. Okay, and now we're going to write 2 ratios. Okay, so I have 2 ratios. They're both true statements. And which one am I going to put in here? Think about it. Okay, and the answer is this one. We need moles of C2H4 on the bottom. And we need moles of H2O on the top because it's in our final answer. So we're going to cancel moles of C2H4. This is the last man standing. It goes there. So now it's just simply everything on the top divided by everything on the bottom. So 3 times 2 divided by 1 is 6. And that's our answer. So what it means is if we put in 3 moles of C2H4, we're going to get 6 moles of H2O. And that makes sense because you get 2 moles of H2O for every 1 mole you put in. If you put in 3, you're going to get twice that much, which is 6 right there. Okay, all right, so let's go on. Okay, the next one, B, is for you to do. Okay, since we've already seen how to do a grams to grams, I'm going to go ahead and just do this one. All right, so remember, this is one's going to stretch all the way across the page. All right, so pull this back over here. So it's how many grams of O2. So I'm just going to go ahead right away and write grams of O2. That's what we're looking for. It's asking how many. So there it is way over on the right, is required to produce 8.3 grams of CO2. So way over here is 8.3 grams of CO2. Okay, so let's come over here and look at our graphic organizer to figure out how many conversions that's going to be. So CO2 in grams, that's what we're interested in. That's the 8.3. And the question is how many grams of O2. So here's O2 and here's grams down here, so it's asking how many, so that's the question mark. So we need to get from 8.3 to here. We have to go up into the equation, come across, and come back down out of the equation. Okay, so it's going to be a 3-step process. All right, so I'm going to go ahead and draw 3 boxes. All right. So what's our first conversion going to be? It's going to be to get us from grams into moles of CO2. So we need the molar mass conversion for CO2. So from here to here, that's the conversion. Okay. I'm no longer going to write the equation again. We know where it came from. It came from here. So we just make a ratio out of it. Okay, so which one of these two goes up there? Well, it starts off with grams of CO2. Grams of CO2 doesn't end up in our final answer, so we have to make that cancel out. So it's going to be this one. Okay, so this grams of CO2 cancels with grams of CO2. Okay, great. So now let's keep going. So now we need to get from CO2 to oxygen. We need to move over here. So the relationship is this one right here. There's 3 moles of oxygen equals 2 CO2. In other words, if you put in 3 moles of oxygen, you're going to come out with 2 moles of CO2. So those two are going to be equal. There's the equation. We'll do the ratio. Okay. So choose which one goes up here. Well, we have moles of CO2 right now active, and we need that to go away because it doesn't appear in our final answer. So we need to pick this one, the one with moles of CO2 on the bottom. Okay, so moles of CO2 cancels with moles of CO2. And we're off to our last one. So now we're sitting in this box right here. We just moved from there to there. Now we're here. We need to get out here. So our conversion is going to be the molar mass for oxygen. 1 mole equals 32 grams. Okay, there's the two ratios. Which one is going to go into this box? Well, we need moles of O2 to cancel out because it's not in our final answer, and we need grams of O2 to appear, so we're going to go ahead and use this one. Okay, so moles of O2 cancels with moles of O2. Last man standing right there. That's the unit in your final answer, so you know that you have everything set up. So now to get the answer, it's 8.3 times 1 times 3 times 32 divided by 44.02 divided by 2 divided by 1. Let's go ahead and do that one. And I get 9.1. 9.05, we're going to round it to 9.1 because we're limited to two significant figures because of that. And that was actually 4. I just abbreviated by cutting off the 0.00. So that's our limiting significant figures. So there's our answer right there. Okay, so again, interpret what this is saying. It's saying that if you want to get 8.3 grams of CO2, you're going to need to put in 9.1 grams of O2. And that assumes that you have enough CH4, that you don't run out of CH4. That's always an assumption when you do this. You don't run out of any of the other compounds or elements, okay? All right, so that takes care of that. Let's move on to D. How many moles of O2? So real quickly, I'm just going to write over here real quickly, moles O2, because it's asking how many, so that's what I'm trying to find. Are required to make 12.52 grams of H2O. So over here, what we know, again, the math equation is asking us for, it wants to know, the chemical equation wants to know what we're going to, how much of this we need to end up with this. So the chemical equation is moving from left to right, from here to here. But the math equation moves in the other direction, okay? So it's from where we start. So we start with 12.52 grams of H2O. So now let's see how many conversions we're going to need. Okay, so grams of H2O is going to be right here in this box. That's 12.52. And we're trying to find out how many moles of O2 are required. So here's moles up here, and here's O2, so that's our question mark. So chemically, as I was saying, it's moving from left to right across that way, but mathematically we're starting here and we're moving back to here. So the math equation starts at that and moves from left to right to come up with the question mark there. Okay, now how many conversions is that? You need 1 to get into the equation, that's the molar mass conversion, and then you need 1 to go from moles of H2O to moles of O2, and that will be your final answer here. Okay. All right, so let's go ahead. We're gonna set up 2 boxes. Right. Okay, so our first conversion we said is going to be that molar mass conversion to get from here into here. Okay, so which of these two ratios goes in here? Well, we need grams of H2O to cancel out, so it's going to be the one with grams of H2O on the bottom. Okay, so grams of H2O cancels with grams of H2O. So right now, after we've done that, we have some number there in that box, but we're not going to compute it. Now we're going to go straight from moles of H2O, which is where we are right there, to moles of O2. So that's the relation between this and this, these two. We don't care about any of the others there. Okay, so you got 2 ratios. Which one are you going to put there? You got 2 ways to tell. Okay, so you need moles of H2O to cancel. This isn't in the final answer, so you got to get that to cancel, so you're going to use this one. Okay, so moles of H2O cancels with moles of H2O. The unit on top at the end is this one, which is what you want for your final answer. So everything is set up properly. So multiply everything on the top, 12.52 times 1 times 3, divided by everything on the bottom, divided by 18.02, divided by 2. So go ahead and do that. And we come up with 1.042. Okay, and that's 4 significant figures because we have 4 significant figures there and there. These numbers, the moles, are standards, so we don't they don't limit the significant figures. Okay, so there is your answer. Okay, again, go back and watch any of these a second time if you don't get it. That's the nice thing about having a video. Okay, let's go on. G. So it's asking how many grams of O2. So I'm going to come way over here. That's what you're trying to find out at the end of the problem. Grams of O2 will be produced by 5.67 moles of H2O. So way over here, we've got 5.67 moles. So let's go to our organizer, figure out how many conversions that's going to be. So we're trying to find grams of O2. Here's O2. Here's the grams row, so that's the question mark. We're trying to find out grams of O2. And we start with 5.67 moles of H2O. So this is moles, and here's H2O, so that's 5.67. What's this? Okay, so we're starting here. We need to get here, so the way you get there is from moles of H2O to moles of O2. And then from moles of O2 out using the molar mass conversion to get to grams of O2. So it's a 2 conversion process. 1, 2. All right, so let's go ahead and write that out. So the first one is going to be 2H2O, 3O2, same one we used in the last part of this problem. So these two are the relationship. Let's go ahead and draw our boxes first, actually. By the way, let me make a point that I just noticed that we haven't talked about yet, is these letters that come after are states, and this stands for gas. It doesn't stand for grams. So that means it's H2O gas. That's water vapor. Carbon dioxide is always a gas. Oxygen is always a gas. CH4 is always a gas. So it could be an L for liquid, an S for solid, or an AQ for aqueous. We'll get to that one when we deal with solutions, okay? So this does not mean grams, okay? Up here these numbers are dealing in moles up here, okay? All right, so we're gonna write our ratios now. Okay, so which one of these two ratios goes in the first box there? Okay, we gotta get moles of H2O to cancel out because it's not in our final answer, so it's gonna be this one. Moles of H2O cancels with moles of H2O. So right there, if we did that calculation, it would be in this box right here. That's where you'd put that. Okay, so now we're sitting in this box. Now we need to get out using the molar mass conversion. 1 mole equals 32 grams for oxygen. And just for the sake of significant figures, I got to write the 2 zeros there. Okay, which of these two ratios goes in that box right there? Well, we need moles of O2 to cancel out, so it's going to have to be on the bottom, and grams of O2 for our final answer is going to have to be on the top, so it's going to be this one right here. Moles of O2, moles of O2. Everything is canceled except this last unit here, which is going to be in our final answer. So now we multiply everything on top, divide by everything on the bottom. And that gives 272.16. And we can have 3 significant figures, so we're going to just call it 272. That's the answer there. Okay. I noticed there was no E or F here for some reason. I don't know how that, but those are the only ones you need to do. I think maybe I took them out earlier. So that's it. That's all there is for problem 2. So you need to do B. You need to do B. And you need to do H. And there is no E and F, as you can see. Okay? All right. Let's move on to the next problem, problem 3. So let's look at this. So this is a single replacement reaction. Again, that's not something that's relevant to doing these problems, but we're going to be dealing with it very shortly, so I'm just introducing it to you. You have a single element there. You have 2 moles, but it's just one element, Na, sodium. You have water. And then what happens is that Na takes the place of the H2. They swap places, basically. So the Na comes in here with the OH, and then the H2 comes out by itself. So you started off with Na by itself, you ended up with H2 by itself. So these two, the H2 and the H2 and the Na basically traded places with each other. It's called a single replacement reaction. Okay. All right, let's go ahead with molar masses. So Na is sodium. That's just a pure element, so it's straight off the periodic table, 22.99. Write it up there. Water, you're going to start to have this one memorized very quickly. It's 18.02. Okay, H2, let's do that one. It's easy. It's 1.01 times 2, so it's 2.02 for H2. And NaOH, that's sodium hydroxide. We haven't done that one yet, so let's take a look at that. It's actually a very kind of a neat number. So sodium is 22.99, oxygen is 16, and hydrogen is 1.01. So let's add those up. 22.99 plus 16 plus 1.01, and it gives you exactly 40. But you still want to put the 2 decimal places after. So it's 40.00. So sodium hydroxide is an easy one to remember as well. So there's all your molar masses. Now if you needed to break them out, you could have done the Na and the O and the H and done it down here. So I gave you room to compute it if you needed to. Okay, let's go ahead and start. Okay, A, how many moles of H2O are needed to produce how many moles of H2O are needed to produce 4 moles of NaOH? Okay, so it's a how many moles H2O. So way over here it's asking how many. So that's moles H2O. So that's what we're trying to find out. Are needed to produce 4 moles, so we'll put that way over here. NaOH. Okay, so if we look up here, we're starting with 4 moles of NaOH, and we need to know how many moles of H2O. So that's simply a moles to moles conversion. That's just one step. Okay, so it's just a 1-box problem. So we'll go ahead and put that here. All right, and there's our conversion. It's 2 H2O produces 2 NaOH. Get on screen here a little better. So there it is, straight from the equation. So now we can set up the ratios. Okay, which one goes in the box? Alright, we need moles of NaOH to cancel out and moles of H2O to appear up on the top for the final answer. So it's going to be this one. Okay, moles NaOH cancels there and there. last man standing is moles of H2O. So now it's 4 times 2 divided by 2 is just 4. That's an easy one. Okay. All right, that takes care of that one. There's your answer for that. Significant figures, well, I only gave you one there, so your answer can only have one. All right. B, again, is boldface, means it's yours to do on your own. Okay. All right. Let's go ahead to C. So again, you notice we're moving a little faster on these, right? Ideally, you're developing a little bit of speed with these, hopefully. But if you're not, you can always go back and watch it a second, a third time, whatever it takes. Okay, so here is a grams to grams. Grams H2O to 3.32 grams of NaOH. That means it's going to be 3 conversions. We kind of know that by now. So it's how many grams of H2O? So way over here. That's what you're trying to find out, how many, and then you're starting with 3.32 grams of NaOH. Okay, so let's go to the graphic organizer. We start with 3.32 grams. We're in the grams row, NaOH, 3.32. And we're trying to find how many grams of H2O. So there's H2O and there's grams, so there's the question mark. So we need to go up, over, and back down. Okay, so the first one is this molar mass conversion for NaOH to get us moles of NaOH. Let's go ahead and draw the boxes first. Okay, so molar mass for NaOH is 1 mole. Okay, so that's our molar mass. So one of these two, which one goes in the box? Well, you need grams of NaOH to cancel out because it doesn't appear in the final answer. So it's going to be this first one. Okay, grams of NaOH cancels there and there. So that puts us right here in this moles of NaOH. Now we need to move from here over to moles of H2O. Again, we have the same relationship. 2 moles of H2O equals 2 moles of NaOH. Okay, which one of these two is going to go in here? Well, we have moles of NaOH sitting there, and that's not in our final answer, so we got to get rid of that. So it's got to be moles of NaOH on the bottom. So that's this one. Moles of NaOH cancels with moles of NaOH. And now we have one last one. We need to come, we're now sitting here in moles of H2O, and we need to get out to grams of H2O. So we need to use this molar mass conversion for water. 1 mole equals 18.02 grams. And it looks like I finally did it. I finally managed to run out of space here. So I'm going to write one ratio on top of the other. So 1 mole. Okay, so there's one of the ratios, and then the other one I'm going to have to write down here. Okay, so which of these two are you going to want to put there? And we need moles of H2O to cancel out, so we need moles of H2O on the bottom. Grams of H2O appears in the final answer, so we need that on top. So it's going to be this. Moles of H2O cancels and cancels. Grams H2O is all that's left. So now we're ready to multiply 3.32 times 1 times 2 times 18.02 divided by 40 divided by 2 divided by 1. And we get 1.49. How many significant figures do we have to work with? 3, because of that. That limits it. So it's 1.495. That's going to round to 1.50. And that's your final answer right there. Okay. The next one is moles to grams. That's one for you to do. Let's go down here. Okay, this one is grams to moles. So how many grams of H2? So way over here, I'm going to write grams H2 because that's what we're looking for. And will be produced by 5.67 moles of H2O. Okay, let's see how many conversions this is going to be. So 5.67 moles of H2O. So here's moles, here's H2O, so that's 5.67. And we're trying to find grams of H2, so here's H2, and grams is down here, so that's where the question mark goes. So we need to get from here to here. So the only way you can move sideways is in the equation, so we're going to move from moles of H2O to moles of H2. And then from moles of H2, using the molar mass, we're going to get grams of H2 for our final answer. So that's 2 conversions, so we need 2 boxes. Okay. All right, so first one is from here to here. So it's 2 H2O for every 1 H2. So these are the 2 that we're interested in. Okay, 2 ratios. Which one goes here? Well, we got to get moles of H2O to cancel out, so it's going to be this one right here. Okay, moles of H2O cancels moles of H2O. Okay, now we need to get from moles of H2 right here into grams for our final answer, and we use the molar mass conversion for that. So there's the conversion, there's the equation, so I'm just going to write the ratios here. Okay, there's the 2 ratios for the molar mass for hydrogen. Which one do you put in here? You're going to put this one here. Moles of H2 cancels there and there. The last unit there, grams of H2, is what's in your final answer. Okay, so you see these can go faster and faster as you get used to doing them. So 5.67 times 1 times 2.02 divided by 2 divided by 1. Seems like we had a problem earlier with exactly the same numbers we did. It's 3 significant figures. It's going to be 5.73. And that's your final answer. It was a different equation, but we ended up with the same number. So anyway, there you go for that. Okay. Again, pause as you need to. I'm just going to move on, keep moving along here. So now we want to know how many moles of NaOH. So we're going to put that way over here. Are produced by 6.8 grams of H2O. Okay, so moles of NaOH is what we're trying to find. There's NaOH, there's moles, so that's the question mark. That's what we're trying to find. And we're starting with 6.8 grams of H2O. There's H2O. There's grams, so it's 6.8. So we need to move up from here to here and then sideways from there to there. So that's 2 conversions. Molar mass gets us to here, and then this relationship gets us from here over to there. All right, so let's go ahead and do that. That's 2 boxes. We'll go ahead and draw those. Okay, first we do the molar mass for water. And I'll just go ahead and write the ratios. Okay, so which one goes in here? We got to get grams of H2O to cancel out, so it's got to be this one right here. Grams of H2O cancels there and there. Okay, and then finally, we've got to go from moles of H2O to moles of H2O to moles of NaOH. So we see that relationship is 2 moles of H2O to 2 moles of NaOH. So I'm going to go ahead and just write those ratios also. And again, I have a little bit of a space issue, so I'm going to write the second one down here. The moles of NaOH is going to go on top. Okay, so which one of these two goes there? We need moles of H2O to cancel, so that's got to be on the bottom. Moles of H2O cancels there and there. The last unit left is moles of NaOH, which is what we want in our final answer. And so it's going to be 6.8 times 1 times 2 divided by 18.02 divided by 2. And that will give us 0.377. We're limited to two significant figures, so we're going to call it 0.38 moles of NaOH. Okay. All right. So that takes care of problem number 3. Okay, so I'm going to wrap the second video. I'm going to go on and do 4 and 5 on a different video. And I'm thinking more and more that this is going to be a full week assignment, okay? So we're going to work on it for period 1 on Wednesday, and then we'll finish it up on Friday for period 2. We'll probably, we'll spend the entire week on it as well. And it's a really important concept to know how to handle this. All right, so we'll see you on the next video.